Okay, so basically, here's what we're coming off of. We're coming off of 4-4, and 4-4 was, hey, here's a bunch of different kinds of equations, and this is what it looks like in this form, and this is what it looks like in this form and that form. And you had to go back and forth between all of them, right? Okay, so the reason that I kind of organized it and taught it to you in this order is because we're going to start word problems today. But the good news is you already know half of it. The half of it meaning I'm going to give you some problems that are word problems in Slope Intercept Form. Then we're going to practice a bunch of those and get comfortable with that. Then I'm going to skip over to point slope and give you point slope word problems. So you already know what point slope is, so you're not learning it from scratch. You're just applying it now. And then we're going to practice a bunch of those. And then the last thing we're going to do is standard form. Standard form is kind of different on its own, okay? So you don't need the highlighters right now. Everybody just kind of hold on to them. There's lots of little noise going on. We need to be able to concentrate. And then I'm going to give you standard, and you're going to practice a bunch of those. Okay. However, when we take the test, which is going to be probably next week, the test is going to have 5 problems only on it. 5 problems, that's it. Okay? There are only 3 types of problems, so there's going to probably be 2 of these, and I'm probably only going to give you 1 of those. Okay? However, here's going to be the tricky part with the test. And it's not going to come out and say, hey, this is a slope intercept word problem. Solve it using slope intercept form. Or, hey, this is a standard form. I'm going to teach you all 3. We're going to practice all 3. And then we're going to kind of mix them all up. And then on the test, it's going to say, reading the information that's given, so you're going to kind of be a detective this week and figure out, you have to know which form to use based on the information given in the problem. And that's going to be my job to help you figure that out. So I kind of want you to see that this is just a extension. It's an extension of moving all those forms around, okay? So, and the good news is, you already know, you don't know that you know, but you know that you know this one. Okay, so remember back to 3-4 when I gave you a table of values, and I gave you a little story. I said, hey, my daughter Emma, she's in Oklahoma. She nannies for 2 kids, right? And she got paid on Christmas week a $50 bonus. They just said, hey, Merry Christmas. Thanks for being a good babysitter. And then she still got her hourly rate or wage of $8, right? What did I ask you to do with that? I said, well, if X is our independent variable, and that means time usually, right? 90% of the time it means a unit of time, days, hours, weeks. So if I said this was the number of hours that Emma worked, and my Y value was the amount of money she got paid, she didn't even work 1 hour that week, and what did she get paid? She got $50. And what do we call that? The beginning value. That was her initial value, or the? Y-intercept. Good, Dylan. The Y-intercept, right? So if we're talking about graphing this, it's going to be called the Y-intercept. But then I said, okay, Emma worked 1 hour. What is her total income now? 58. And after that second hour, it was 66. And you see the pattern from there. Then what did I ask you to do with that table? Turn it into a slope intercept form. And you said Y equals 8x plus 50 without a doubt. So guess what? We're using the information given today to write an equation and do one other little thing. So let's have that take us to problem number 1. You can go ahead and cross out number 3. Okay? All right, so we'll have some time to go over and discuss it. But here's what I want to do. We are detectives, and when you're a detective, I don't know if you ever watch any TV shows where detectives go around trying to solve mysteries. They have this little notepad with them, and they're constantly writing notes in it, right? So we have our highlighters, and we're going to highlight what we feel is the most important information. And I'm going to use green, blue, and yellow. And so, slope intercept form, let's refresh our memory. It shouldn't need a whole lot of refreshing. That the Y equals mx plus b. And that b, I'm going to use green. Green means go. That's where we have to go from, right? So this b, I'm going to have you just write, it's the beginning value. Sometimes you'll hear it or see it written the initial value. It means that's what you're starting out at, okay? And you know that. It's nothing new. And then the x, I used to call it slope. I'm not going to call it slope right now because we're not dealing with rise over run on a graph. We're dealing with real life world problems. So word problems. So I'm going to call it rate of change. Hey, that's what it was in 7th grade, right? Yeah. Rate of change means what's it changing by? So for example, my rate of change is 8. It's changing by $8. So I want you to write the words not slope. We know that's what it is really still, right? But we're going to use rate of change today. Okay. And you're kind of at an advantage because I'm telling you every problem we're doing today, I'm going to give you both of those. You won't have to look for them or seek them out, or they're going to be right there. So I'm going to use green for my rate or for my beginning value and all of my slopes for all week long. Every time I do a notes, I'm going to highlight the slope in blue, and if it's given, I'm going to highlight the y-intercept in green. You can use those colors if you have them. If you have a pink, make it whatever you want. And I have a yellow. I'm going to show you what that's for. So the first thing I'm going to do is read this problem. Lynn is tracking the progress of her plant's growth starting today. So on day 0, before she even started tracking it, it's 5 centimeters tall. What do you think that would be? The beginning value. So in my green, it's, yes, if I were to graph it, it's going to be my y-intercept. So currently, the plant is 5 centimeters tall. I haven't watered it. I haven't, other than just measuring it, that's all I know. The next sentence says, every day the plant is going to grow 1.5 centimeters. That's my what? Rate of change. So I'm using blue. Whatever color you use, I don't care. Just keep it consistent during the week. So I'm also going to highlight the word grows. Do you know why? Because a rate of change could be going up or down. It could be positive or negative. And what does growing usually mean? That my rate of change is increasing. So we're going to use a positive, okay? So then in yellow, I'm going to highlight, what does Mrs. Z want me to know and be able to answer after I get all this done? So, just what will the height of the plant be after 20 days? You don't have to highlight that. That was an accident. So, because this is literally only 5 questions on the assessment, they're really detailed. Like, I'm asking you to do a lot in one problem. You know, like what a performance task is sometimes? First you got to do this, then you got to do that. That's kind of what this is, so get ready for it. Yeah. No, as long as you follow it through with the correct steps. After that, it's not going to count everything against you. So my advice to you is going to be make a table first. You'll understand why in a second. And then I'm going to suggest that you write the equation. Okay? So guess what? You have to do this for all 3 of them, or for all the problems. You're going to make a table. You're going to write an equation. Then you're going to use that equation to answer the question. And then after the question, oh my goodness, you're going to write one ordered pair. And if I was feeling real mean, I would add step 5 in there. And step 5 would be graph it. Meaning, what would that look like on a graph? Well, I'm going to show you, but I'm not going to hold you accountable for that this day. So, here's me making a table. This is my advice to you. I'm going to explain why. This is my X. This is the Y. And what you have to do to understand about your table is, well, what did I say that the X value usually is? It's a unit of time. It's my independent variable. Nothing can change this. What depends on what? Well, the height of the plant depends on how many days she watered it or let it grow, right? So this is the dependent. We're going to use H for height, and we're going to use D for day. Okay? You'll know why I had you write that in a minute. You're going to fill out the table like I know that you know how to do. Before she even started watering it and measuring it, she found that it was 5 centimeters. After 1 day of sunlight and water, it grew 1.5 centimeters. So it's now 6.5 centimeters tall, and you can probably figure out on your own how tall it is after 2. Kind of weird, Plant grows exactly the same amount every day. Not usually a linear example, but in this case it is. Okay, do we have our table? Good with step 1? Easy. Step 2. Now this is where I want to point something out to you. I know, I see pencils moving already, and I bet you, half of you here have y equals 1.5x plus 5, and you're not wrong. But there's going to be one thing that I'm going to suggest you change a little bit to help you. Because if you use y equals 1.5x plus 5, when you get to this yellow question, I found, trust me, after 19 years, I found this is where kids they get to this point, and they go, oh shoot, where do I put the 20? Well, I want to know if this happens for 20 days, and I kid you not, would you believe me if I told you that there were kids who took this table and extended it all the way out and did day 3 would be another 1.5 centimeters. Day 4 would be, and they did it all the way up to 20. And I said, you're missing the point. You don't have to do that when you have this. This is your golden ticket. If you can get the equation, you can solve any problem you want within a matter of seconds, right? You just have to know where to put the 20. And somebody said, well, I don't know. Where do you put it? You substitute it for the x, absolutely, because that's the number of days. Ben, go ahead.
Why do we have to have the table?
Yeah, the table is just to kind of reinforce what we learned at the end of Unit 3, and it is linear, so it's a reinforcement. Yes, I'm wanting to make sure you can do the table. Okay, so Dennis knew, put it in for x. It just kind of made sense to him. However, there are still people who get confused. So here's your solution. This right here. I want you to put a nice little... Yes. Hey, so Ben kind of had a question about why is the table necessary, because you can kind of use it to help you write your new equation. So instead of x, I'm going to use d. And instead of y, I'm going to use h. So watch. I'm going to create a new and improved equation, and instead of y equals 1.5x plus 5, it's going to be h equals 1.5d plus 5. And here's why. Because the height of the plant is going to equal 1.5 times the number of days she waters it for. Oh, yeah, and it was 5 to start with. Does that make sense? I mean, it should. So now, let's rewind about 3 minutes ago when I said, what will the height of the plant be after 20? D for days. Now where does the 20 go? Right in for D. It's like, makes it so simple. And I'm telling you, just trust me, after years and years, I know if kids don't use H and D and they just use Y and X, they put it in the wrong spot. So watch. The height after 1.5 per day, after 20 days of growth, that's going to give me 30 plus 5. The height will be 35 centimeters. Okay, so stop, because I'm still not done. I just answered the question. Hey, it's going to be 35. Write an ordered pair. What does she mean by that? Well, if we were to go graph it, instead of writing x comma y, what is x? The days. What is y? Height. So if I asked you to write an ordered pair to summarize all of this, what would it be? What does 35 mean? Like, you know the worst part about word problems? Kids are like, they are little robots. They get an answer and I go, what does 35 mean? They go, I don't know. I just know. I just solved it. It means what?
The height of the grass after 20 days?
Yes. It means after 20 days of growing, that's the height of it. How could I write that as an ordered pair? 20, comma, 35. Okay? And so guess what? If I threw a little step 5 in there and ask you to graph it, that would look like this. Oh, the x is the number of days, the y is the number of centimeters, and on day 0, what's that? Dylan said it earlier, it's my y-intercept. Oh, and every day that goes by, it's growing an inch and a half, or a centimeter and a half. Oh, hey, that's linear. And then at this point, we would have to stop and say, should I put an arrow? Do you think this plant is going to grow forever and ever and ever and never stop? It's probably at one point when Lynn measures, it's gonna stop growing. So it may not have an arrow. It may maintain the same height. Then if she forgets to water it, it might die. This is interpreting graphs. Remember how when we skipped section 3.5? That's what that was. So that's why I'm throwing that in there. Okay? So, look at what we did. Wow, that's a lot of work. I made a table. I put the D and the H. I wrote an equation. I used the equation to answer the question. I used the answer to make an ordered pair. Maybe I sketched a little graph. Yes, Dennis?
Will we get it wrong if we don't label it answer?
No. I mean, I want this there. That's right.
So you want us to do step 5?
Yeah, we'll see. Not for right now. Okay, so Mr. Thompson has a ginormous dog, and it's more like a small pony. He weighs 260 pounds. This is a big fat dog. His dog needs to go on a diet, okay? I know, it's crazy. So he puts him on a diet, and the diet is so successful that he loses 4 pounds a month. Okay? So let's get out our highlighters. What information do we know? What's the beginning value? 260. Okay. Rate of change. Not only do I want to highlight the 4, what other word should I highlight? Loses. Because my rate of change, thank God in this case, is not going up. It's going down. What's that going to mean you have to put for your rate of change? A negative. Good. And then, his owner has a goal. His owner's goal is for this dog to lose 100 pounds. He wants him to weigh 160, not 260. So my question is, how long is it going to take? Well, it's only 4 pounds a month, so it's going to take a while. And this, I want to bring up a really good point. At this point, usually in the game, I have a lot of people shouting answers because they know it. They figured it out because I gave an easy kind of problem to figure out, right? He has 100 pounds to lose and 4 pounds per month. I know you know the answer is 25, right? Because you're smart. But guess what? Part of algebra is justifying your work. Algebraically prove to me that it's 25, okay? Up here. Eyes up here. All right? So, what we're going to do is we're going to make our table. So go with me on this. X and Y. Possibly the most important part right now is what is X and what is Y. X is actually what? What's our time period? Months. And what is our Y? What's our other variable? What depends on that? Yeah, you can put M. Yes, absolutely. I just want to make sure. Yeah, and then what Dylan says is the amount of weight. So if you want to use W for weight or if you want to use P for pounds, I don't really care. We'll just do P for pounds. So M and P. So he put his dog on the scale on day 1 and he weighed. And according to his records, after 1 month on the diet, now he weighs what? Hey, slow and steady, right? 4 pounds, 256. Whoa, 2 months into it. Now he weighs. So we're getting there. And it's a linear relationship. Let's write the equation. Go. So you're probably used to this. Y equals, be careful because what should you put? I am going to recommend that you say that the number of pounds this dog weighs is going to equal negative 4 pounds per month, and his starting weight goes here. At this point, I have kids say, hey, I have a question, and it might be what your hand's up for. He says, can I start at 260? To me, is that what you're going to say? No? Okay, go ahead.
We just leave it as X.
Yes, if you're confident when it comes time to answer this question, you know where to put that, yeah. So somebody says, it makes more sense that I'm going to put the starting value first, and then the rate of change after. So he's starting at 260 and losing 4 pounds a month. Can you write it whichever way you want? Yeah. Okay? I don't really care. All right. The important part is you have exactly what you need to be able to answer that question in yellow. How many months was his dog on the diet for if his weight came down to 160 pounds? I just need to know where to put that. That's why I put P, because now I know the 160 goes there and not there. If I put it there, it meant he was on the diet for 160 months. Oh my gosh, that's like longer than his life, right? So I'm going to put 160 here. Go ahead, do the math with me. And by the way, I am flying through this part because you should be able to solve this equation quickly. Divide, solve for m, and all of you who said, I know it's 25 months, a little over 2 years, you just proved it to me. Algebraically, by justifying your work, I know that you know when a problem comes that you can't do in your head, you have the tools to be able to do it. Does this make sense? We're not done though. What does 25 mean? It means that's how long it's going to take him in months to what? Weigh 160 pounds. So if you do months, comma, pounds, that's that. Okay? What do you think this table or graph would look like? If this is the number of months and this is the dog's weight, which we could use LBS, his weight's starting way up here. It's going to keep going down. Hey, you think that line will ever touch that axis? I hope not. Right? And those of you who laughed, you get it. You know how to interpret a graph, and based on your reaction, because what would that mean if that line touched that axis? He weighs 0 pounds, right? So eventually he gains and he maintains, and what usually happens when people who go on diets, and it goes back up and so on. That's 3-5. That's interpreting a graph. Awesome. I got one more to do with you. Ready? All right. How many of you have ever saved your money up for something? Okay. So stay with me. Stay with me. Stay with me. So this guy Paul says, "Hey, there's this $2,000 item I want. I have $350 right now, and my parents told me that they, as long as I do my chores around the house, they're going to pay me $150 a month. I'm going to put that in the bank. I'm going to watch that $350 grow. I'm never going to withdraw. How long will it take me until I can get to that $2,000? Okay, let's do this process together. Ready? X, Y. I'm going to kind of fly through this. X is the number of months, and this is the S. Or I'm going to use a lowercase cursive s, which is usually what you do. S's sometimes look like 5s. So before he even started saving, he had $350. After that first deposit and that first month, now he has $500. After that second deposit, he has $650. Am I going to seriously continue going up by $150 until I get to $2,000? No. You're going to write an equation in Slope Intercept Form and plug a value in. So I hope you know. And by the way, he started with $350. And what word should I deposit along with the $150 for my rate of change? Did I say what word should I deposit? Oh, hint, hint. What word should I highlight? Deposit. So 150x plus 350. But you might want to write his savings is going to be equal to $150 for every month. Oh, and he started with $350. From here, you just plug it in. But what do I plug in? Oh, guess what? 2 parts. I want you to look at these problems. I'm asking you 2 questions, so guess what? You need to have 2 answers. That's usually what 2 questions mean. Please look up here and listen. The first one says, if he wants to save $2,000, how long will it take him? The other one says, if he saves for a full year, how much will he have? I ask you one of each. So what you have to do is say, what the heck is 2,000 and where does it go? And full year, they don't even give me a number. What's my equation written in? Months. So what should I use? 12. So here, I'm going to make my savings equal 2,000 and plug it in. And here, I'm going to make the number of months 12 and plug it in. Are you with me? This is not hard, is it? If you are following along and taking notes and using half of your brain, you'll get this, right? If you aren't doing those things, you're probably not going to. Okay? So, The savings amount that is desired is $2,000. 150 per month plus what he started with, and then solve it. You should be doing equations in your sleep by January 16th of 8th grade algebra. What does 11 mean? I don't know. You got to tell me. You got to, like, there was a year where I made kids write out a sentence in English with capitals and periods and everything, telling me, what does 11 mean? It means that, go. After 11,
It took 11 months for
yes, that's it. It'll take him 11 months to save $2,000. That means I know what you know what that 11 means, Ben. So could you just put 11, comma 2,000? Do you think there are people that can put 11, 2,000 and still not explain what the 11 means? Yeah, there are. I need you to be able to understand that, okay? So then now where am I putting the 12? Now I want to know, what will the savings be if I save $150 every month for a full year? Oh, and don't forget about that $350 that I had to begin with. Okay? This one's a little easier. What's that mean? It means that after a full year, I still have to put 12, of $2,150. Does anybody see a shorter way to do that? Using maybe the information? What could you do, Dorian? Exactly. So he said, well, if 11 months, it'll take him for that. 12 months is one more month. Add in an extra $150. But guess what? What if I don't ask you that question? Right? So do you see why you have got to learn the steps? I would like you to try number 4. I don't know if you could even fathom, but there used to be a time where you would have to pay per text. Every text you sent and received would cost you 15 cents. You guys would be like, oh, millions of dollars, some of you, right? Okay, there used to be a day. Not all of you, right? So go ahead and work through number 4 together.